Alright, so we're going to do a few problems for review for your test. So first of all, make sure that you know all the trigonometric definitions here. So if you have a right triangle, you want to make sure that you have memorized the SOHCAHTOA. So for sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. You have to know that, right? And so we have a right triangle. You're going to use Pythagorean's theorem to find the missing side. And so we need to do that first. And so we will, I'll work down here. So 2, I don't know this side. I've always used A, B, and C, so I'm going to call this one B, and my hypotenuse is C. So I have A squared plus B squared equals C squared. My A is 2 squared plus B, I don't know, and my C square root of 13 squared. 2 squared is 4 plus my B squared. Square root of 13 squared is 13. Right, you want to isolate your B squared. 13 minus 4 is going to be 9, which is nice because it is a perfect square. So square root of B squared will just be 3. And it is a length, so it's going to be positive. So B equals 3. And then we can work and get our answers. So sine of theta for our first one is going to be opposite over hypotenuse. So, and your theta is here. All right, so you're here. The opposite will be 2 over hypotenuse, square root of 13. You have to clean that up. You're not allowed to leave a radical in the denominator. So square root of 13 over square root of 13 will rationalize. This will give you a 13. And you will have 2 square root of 13 on the numerator. So we should be good there. On the next one, we'll do cosine of theta. And cosine is adjacent over hypotenuse. All right, theta is still here. Adjacent will be 3 over square root of 13. Still can't have that radical in the denominator, so you have to rationalize. Square root of 13 over square root of 13. So you have 3 square root of 13 over 13. All right, next we will do tangent of theta is opposite over adjacent. Sorry, that's an O, opposite over adjacent from your triangle. Here's your theta. Opposite is 2, adjacent is 3, and that one you don't have to do anything with. All right, so now we'll do the cousins, cosecant of theta. So we're going to flip the sign over. We could actually go back to the first form, 2 over square root of 13, and save ourselves some work. Flip this one over, and we will have square root of 13 over 2, and we won't have to do anything else. You could flip any one of them over, All right. And then we will do secant of theta, which will be the cousin to cosine. And we could go to this first one and then flip it over. So it would be square root of 13 over 3. Then we don't have to rationalize. And then we need cotan of theta. And that will be 3 over 2. And you should be good with those. So it is a matter of memorizing. You had to do Pythagorean's theorem to finish your triangle. And you had to know all these. You had to know how to rationalize. Next, you want to remember the theorem about complementary angles. And so we have the cofunction of complementary angles, that they are equal. So like if we have the sine of 30 degrees, if we have the cosine of 60 degrees, it's going to be equal because it's a complement. It's the cofunction to sine. Sine and cosine are cofunctions. 60 is a complementary angle to 30. They add up to 90 degrees. So they're going to be equal. All right. Tan and cotan are cofunctions, and 40 and 50 are complementary angles. So those two are going to be equal, and the same for secant and cosecant. So if I had a problem like sine of 72 degrees, so a weird one that you might not know, you wouldn't know. You know, it's not one that we're going to necessarily know. And minus cosine of 18 degrees. And they say don't use a calculator, right? So figure it out, right? You can figure it out because these are cofunctions, sine and cosine, and 72 and 18 add up to 90. So these are going to be equal. So whatever this one is, this is equal to this one. When you subtract them, it's going to be 0. And you can actually check it on your calculator if you put it in your calculator. And we do, let's make sure I am in degree mode. All right. All right, and if I do sine and 72, and it's going to be weird. Okay. And if I do cosine, let me move it over, cosine of 18, and notice they're exactly the same. So when you subtract something that is the same, you are going to get 0. You can also have these in like a division form. Whoops, sorry about that. So if we have like cosine of 24 degrees over sine of, let's see, 80. Sorry, that would make 80. I think I'm good there. Right. That should equal what? Let's try it. All right. So if we do cosine of 24 divided by sine of 66 which one? Because they're going to be equal. So those come from, whoops, I didn't need that, sorry. Those come from this theorem. And it's because I have used things that add up to 90. If they didn't add to 90, I couldn't use this theorem. All right, we're going to look at one more right triangle. And we're given 2 sides. And we know it's a right triangle, so we know one of the angles. And we're asked to find the other side and the other 2 angles. So you have 2 sides. You know A, which is opposite your angle A. So this is going to be 4. And it may not let me write on that since it's a, yeah, it will. A picture. And C is 8. So you're going to use Pythagorean's theorem to find B. So A squared plus B squared equals C squared. All right. And if we had class, I would not be doing all these, okay? I think that you would know these. I feel bad for not having class, so I'm doing more than I normally would on a review day. I think that you guys know these. All right, so my A is 4, and I'm going to square it. My B, I don't know. My C is 8, and I'm going to square it. So 4 squared is 16. B, I don't know. 8 squared is 64. And so I need to isolate the B squared. So I am going to do 64 minus 16. 48. So B squared. And then I have to take the square root. And so in the directions, which I didn't pull over here, let's see. Let me turn that piece off. See if I can pull it back up. They want it to the nearest hundredth. So I don't have to simplify the radical. I can just go with my calculator. So I can do second square root of 48. And to the nearest hundredth is going to be 6.93. Because of what they ask for. That is to the nearest hundredth. Okay, so that is one thing. All right. Now, I'm going to have to use my SOHCAHTOA to get one of those angles, and let's go ahead and see about getting the smaller angle. So let's try for A, and let's see, if we're standing on A, we could use opposite over hypotenuse. So opposite over hypotenuse, that is sine is so. All right, so sine of A would be opposite, which would be 4 over hypotenuse. So sine of A is opposite over hypotenuse, which is 4 over 8 is 1/2. Right, so if we do inverse sine of 1/2, we should get A. And we might know 1/2 is one we've done a bunch, but we'll go through the steps. Right, so we can do second sine inverse of, you can put 0.5 or you can do 1 divided by 2. Close, enter, and that is 30 degrees. So A equals 30 degrees. Right, this one is 90 degrees, so our C is 90 degrees, which means B will have to be 60 degrees because they add up to 180 degrees. All right, here's our fourth question we're going to look at, and this one is using your law of sines. And your law of sines can be used to help you find your sides and angles. So this one we are given angle, angle, side. And so I would probably go ahead and find the other angle, and I would find it myself just by adding up the angles to be 180. You don't have to do that, but that is probably what I would do. All right, so I will find angle A. So I have 95 and 60. So 180 minus 95 minus 60 equals 25. Right, so that takes care of angle A, and I probably shouldn't have put that. Right, so angle A is 25 degrees. All right, and now we'll find our sides, and so we'll find the smallest side first, and so we do have one pair. We'll use those, and so we're going to find a side, and so we will put the side on the top. So we will use our law of sines, so we'll use 7 over the sine of 95 equals A over, that's an A, sorry, over the sine of 25, and we can solve for the small a. All right, and so we will cross multiply. We want to solve for a, so we will just multiply this by the 7, this times the 7, and divide it by the sine of 95, and the a will be isolated. All right, let's see. So this was our pair. So 7 over sine of 95. And we're looking for a. So 7 over sine of 25 divided by sine of 95 will equal a. So 7 sine 25 divided by sine of 95 should equal our small a. And the directions said for the sides go to 2 decimal places. All right, so let's try that. So 7 times the sine of 25, close, and I'm going to divide all of that by the sine of 95, close, enter. And I am getting 2.96, and I believe it was a 9. And that would push my 6 up, so 2.97 will be A. All right, and so I still need to find B. All right, so I would go with the same pair that I had originally. So 7 over sine of 95, because those were both given. And I'm going to find B over sine of 60. Right, and again, your B is here, so we just need to get this one up here. So sine of 7 times the sine of 60 divided by the sine of 95 will equal the B. That one will also need to go to 2 decimal places. So 7 times the sine of 60 divided by sine 95, close, enter. 6.08, and your 5 is going to push you up. So 6.09, I'm going to go ahead because the calculator will disappear when I write on this screen. So 6.09. And so this was a angle side that they gave us, and we used a law of sines to solve it. Right. Next we have a triangle, and we have 2 sides and an angle are given. Determine whether the given information results in 1 triangle, 2 triangles, or no triangle. So they're giving you a hint there. This is the ambiguous case, so you're going to have to decide which it is. We'll just draw ourselves a picture. So there, and it doesn't really matter how your picture looks. So they're giving us a side-side angle. All right, so we'll call this A, B, C. All right, and so this should be A, and this should be B, and this should be C. All right, and my picture may not be realistic. This is 60 degrees. This side is 10. This side is 9. And that's all I know. Okay, so it is a side-side angle. That is the ambiguous case. All right, so we'll see what we can figure out. We do have a pair, and we have a setup to make another pair. So we can figure out angle B with the law of sines, and that's what we'll go for. So that is what we're going to work on first, and we're going to be looking for an angle. So we should put that part on top. All right, and so we'll work with what we have. So we have sine of 60 over 10 equals, right? We don't know the B, so we have sine of B over 9. Now, we'll do our cross multiplication. So we're going to go this way. Great. And so I'll have 9 times, sorry, my colors are off. 9 times the sine of 60 divided by 10 equals the sine of B. All right, so we'll put this in our calculator. None of these seem to be working out like they did for me before. That's okay. All right, so 9 sine of 60 close divided by 10, enter. Right, now that is the sine of B, okay, but I don't want the sine of B, I want B. So I'm going to leave that sitting in my calculator, and I'm going to do inverse sine. So I'm going to do second sine inverse, and then I'm going to do second answer to make that value go into there, and enter. And that will give me what B should be. All right, so I'm going to write what these pieces were, and they want the angles to be 2 places. So I could, if I was going to write this out, I would, annoying. All right, so 0.779422. All right, but I kept it in my calculator. Remember, I did that. All right, so then I did sine inverse, of that by keeping it in my calculator. And so for my B, I have 51.21. Okay. All right, and so now for my angle C, I can get that. Oh, no, I need to check something. All right, I need to check right here. All right, before I go further. All right, so I have my A, I have my side B, which I found. I need to know if I could have another triangle. All right. So I need to know, is another option possible? Is another triangle possible? All right. With a different angle instead of this 51.21. All right. And so what I have to look at is 180 minus this 51.21. If that angle is a possibility for this angle instead. So I go on my calculator and do 180 minus 51.21 and see if that angle could be possible here. But 128.79 is not going to be possible because I also have an angle of 60. 60 plus 128.79, just those two would be over 180. That would be 188, and you still have a third angle. So that is not going to be possible. So this would give us 128.79. So this answer is no. So this will result in a single one triangle. So in this particular one, there is only one triangle. You did look at what you needed to, but there was not a second triangle. Okay, so you had to think about that when you found this second angle, but it did not result in another triangle. Okay, let's see what else we have to find on this one. We need to go ahead and find the third angle, but this was what I wanted you to really review. Find your third angle. I would just do 180 minus these two. So minus 60 minus 51.21. And this will give you your other angle. 180 minus 60 minus 51.21. And that would give us 68.79. For angle C. And then you would need to find side C. And you're just going to go back with your law of sines. Okay, I'm going to skip doing it. I want to do one more of this kind of problem for you with the ambiguous case. All right, we're going to look at one more of those side-side angle problems. All right, so we have two sides and an angle given below. So we know it's going to be the ambiguous case, and we're going to have to decide whether it is one triangle, two triangles, or no triangles. All right, and I'm going to draw a picture, but it might not be to scale, okay? So I have, and one angle is 20 degrees, so that's a pretty skinny triangle. All right, so let's see, we'll make that one skinny. All right, so we'll make this B. A, B, and C. All right, and we'll make this 8, and this 10, and this is 20 degrees, and this is side A. Let's see. So we know 20 degrees matches up to side B. So we have a pair, and side C, angle C and 10, and angle A and side A we don't know. Okay, so we should go with the law of sines, and we're going to look for this one. We have a partial here, and so we're going to look for angle C. Since we're looking for an angle, we'll put the angles on top. We'll work with the pair that we have. We'll use law of sines. So we will do sine of B, so sine of 20 over 8 equals, right? And we'll work with this pair, sine of C over 10. All right, so we want to solve for C, and we'll multiply this way. So 10 times the sine of 20 divided by 8 will give us the sine of C, and then we'll do inverse. All right, so we're going to pull a calculator, and we're going to clear 10 times the sine of 20, close, divided by 8, enter. All right, I'm going to keep that value in my calculator. I'm going to go ahead and do second sine inverse, and I'm going to do second answer, close, and that way I'm putting that whole value in there. I'm not getting any round off error. Enter. All right, and I can go to 2 decimal places, and this will be for C, 25.31. So C, so we actually did, so I have to remember this. See if Mrs. H's brain can work there. So I went ahead and did sine inverse, and so C is 25.31. So you can look back at the video, okay? Okay, so now is where we have to check if there is a possibility for another triangle. So we need to do 180 minus 25.31. If it's possible, whatever that is going to be that angle. All right, so 180 minus 25.31, enter. So it would be 154.69. All right, and we have one that is 20. That would give us 174.69. We don't know the other one yet. So it is possible. So yes, it's possible. So there's going to be two triangles. So let's go ahead and get the third angle on this triangle. And then we'll come back and we have to get the other pieces here. So the third angle, so this will be the C on this triangle. On the alternate, all right, and so the A on this alternate triangle will be 180 minus the other two. So 180 minus 20 minus, so 180 minus 174.69. Great. All right, so 5.31. All right, so our A, 5.31. The B stays the same. So there, your 174.69 plus 5.31. All right, so that's your angles, and your other two sides stay as they are, and you will have to find that other side that you don't know. All right, so the side that is opposite that A. So we have found, we have to go back and finish the other pieces. So this one is the alternate. Let's find the rest for this triangle. All right, so for our original triangle, let's find this A. So this is our original. So our original A will be 180 minus 20 minus 25.31 180 minus 20 minus 25.31, 134.69. All right, so that's on our original. Right, and on this one, the only thing we didn't find is the side A. So we would need to do that using law of sines now. So we will continue with it. Use the pair that you had. So what we had was 8 and sine of 20. And we're looking for a side now. So let's put those on top. So 8 and sine of 20, and I can move it down in a second. And now we're looking for A. And sine of 134.69. All right, so we want A, so we'll multiply this times 8, this times 8, and divide by sine of 20. So 8 times sine of 134.69 divide by sine of 20 will equal A. Put that in your calculator. 8 sine 134.68, close, divide by sine of 20, close, enter. So 16.63. That is your A from your original triangle. All right. From this triangle, your pieces that you had you had the 20, you had the 8, and you had the 10. Those are staying. The B, the C, and the 20, right? Our angle C here was 154.69. Our angle A was 5.31. This angle. So now we have all the angles. This side we will have to find. It's not going to be the same as the other triangle. And this one, so we'll have to find it. I need to label a little bit here. This is B, angle B. This is angle C, alternate. These get a little crazy. All right, so this is A alternate. And that is what I need to find now. All right, and I'll still use my original pair. I'm looking for a side, so I'm going to do side on top, 8 over sine of 20. My A over sine of 5.31, right? And I will go this way. So 8 sine of 5.31 divided by sine of 20 will equal A. All right, go to your calculator, clear it. So 8 sine 5.31 close divided by sine 20 close, enter, and I get 2.16. A 4 is not enough to push it up. So that is side A on your alternate triangle. So this is the case where you get two triangles and you would need to find all those pieces. So that is probably the hardest question that you would have. All right, so we're going to look at this problem. We have an example here where we have side angle side. In this problem, we do not have a complete pair. We have angle B with side B. We have side A, angle C, and side C, but we do not have a complete pair. You have to have a complete pair to use the law of sines. So we are going to have to go with the law of cosines. All right, and so we'll go ahead and find side B. All right, so you have to remember these. And so we'll find B squared equals, and it is A squared plus C squared. So the ones you're not looking for, minus 2 AC cosine of B, the one you are looking for. All right, and then we'll fill in what we have. I believe we're good here. All right, so B we don't know. A we know, so we have 6 squared. C we know, 2 times A. I'm going to label these. That's a 6. This is a 7. And cosine of B. All right, so we have 36 plus 49 minus, all right, let's get some numbers here. 12 times 7. 12 times 7, 84. All right. Oh, but we know B. Angle B is 20 degrees. So I could have filled that in. Let's fix that. So I've got 85, let's see, b squared equals 85 minus 84 cosine of 20. All right, and let's see. So 85 minus 84 cosine of 20, enter. All right, that is equal to b squared all right, now I'm going to keep that in my calculator. I should have made my screen smaller so I could keep that calculator up there. I'm going to do second square root. I'm going to save that value and then I can dump it back in there so that I'm not going to get so much round off error. Okay, so what I want to do is take the square root of that whole thing, all right, to get just b. All right, so I put that whole value in. So I simplified my numbers as much as I could, entered that, and now I'm going to get the square root of this. Okay, so I am going to do second square root. I am going to dump that value in. So a second answer, close, enter. So B is approximately, let's see how many digits they want. 2 places, so 2.46. Right, and that's going to be here. All right, so now I have a complete pair here and here, and then I can go to law of sines once I have a complete pair. So I'll switch over to law of sines because it's just a little easier to use. And so I'll use that complete pair, and I'll go for the smaller one. Let's see, which should be the angle A. All right, so I'm going to go for an angle, so I'll put the angle on top. So I will do sine of 20 over 2.46 equals sine of A, angle A, over 6. So we'll go this way. All right, so we're going to have 6 times the sine of 20 divided by 2.46 will equal the sine of A. So we're going to have to do inverse sine here. So 6 sine of 20 6 sine of 20 close divided by 2.46 equals, all right, I'm going to keep that value and do inverse sine because I don't want this sine, I want the angle. All right, so you can remember that value. We're going to switch and do sine inverse of this. So 0.834195. So 0.834195, blah, blah, blah. All right, but we're going to do sine inverse of this equals A. So I'll do second sine inverse, but if I do second answer, it will keep all of that. Enter. So A is going to be approximately, and for the angles, they're just asking for 1 decimal place, 2 decimal places for the sides, 56.5. All right, and that will be angle A. Right, for the other angle, I would just add up all the angles to be 180. So to get angle C, and my angle minus 20. All right. So a quick calculator, 180 minus 56.5 minus 20, enter, 103.5. All right, so I did not go back. Let's see. We have C is 7, A. We have everything now. All right. So that's an example of law of sines, and then you had to use law of cosines. All right, we'll do one more problem to use law of cosines. In this problem, we have side, side, side. So again, we do not have a complete pair because we don't know any of the angles. So we cannot use law of sines. We have to use law of cosines. So you can use either form you want. I'm just going to go ahead and use the form I used the last time. So I'm going to use the b squared form. All right, so b squared equals, so the ones I don't have, a squared plus c squared minus 2 times those two sides times the cosine of angle B. All right, fill in what you know. All right, I'm going to label these. This is B, this is C, and this is A. Right, that'll help a little bit. So my B is 5, and I'm going to square it. My A is 12, and I'm going to square it. My C is 8, and I'm going to square it. Minus 2 times my A is 12. My C is 8. And my cosine of angle B. All right, do all the math you can. 5 squared is 25. 12 squared is 144. 8 squared is 64. Minus 2 times 12 is 24. And 24 times 8, I would probably resort to a calculator. 24 times 8 is 192. So 192 cosine of angle B. All right, so we're going to need to get these two moved to the other side. This one is with your variable piece. So 25 minus 144 minus 64. That moves those two to the other side. So 25 minus 144 minus 64. Enter. negative 183. That is moving these two to the left-hand side. So I moved that one, I moved that one. Now I have this equals to negative 192 cosine of B. Going to divide on both sides by negative 192. Right? The two negatives are going to clean up and give you a positive, so we're not going to worry about them. Going to go over here. So I'm going to punch this in the calculator. 183 over 192. This is going to equal my cosine of B. And then I'm going to do cosine inverse because that's not, I want to know B. All right, so I'm going to clear 183 divided by 192. Or if I'd have been really clever, I would have just done the cosine inverse of that. Enter. All right, so I'm going to do cosine inverse of this value. And I'll write that in a minute, okay, because it'll make my calculator disappear. So I'm going to do second cosine inverse, and second answer will put that value in here. Close, and there we go. 17.6, and these want one decimal place. 17.61, all right, will be my angle B. So here I'm doing cosine inverse of this. I'll just put the 183 over 192. This will give me B. All right, so B is approximately 17 point, we said one decimal place, so 17.6 degrees. Okay. So that is one angle and one side. Now I have a pair. Once you have a pair, then you can go to law of sines. Until you do, you have to use law of cosines. All right, and so I'll be finding an angle, so I'll put the angles on the top, and I'll go for the smaller one. All right, so I'm going to, the one I have is the B, so I'm going to put sine of 17.6 over 5 equal to, and C will be my smaller angle. So sine of C over 8. All right, and I will go this way. So 8 times the sine of 17.6 divided by 5 should give me the sine of C, and then I will have to do sine inverse again. So calculator, you need to practice a lot of these. If you haven't done the homework, you're going to be in trouble. Okay, if you have, it's going to be a piece of cake. So 8 sine 17.6, close, divided by 5, enter. All right, but now we want to do sine inverse because we want C. Second sine inverse, second answer to dump that whole value in there, close, enter. 28.9, we're only wanting one decimal place here, will be angle C. 28.9. So we did sine inverse, and we get 28.9 right from there. And the other angle you can get by subtracting. So you don't have to really do law of sines again. That was C, sine inverse. And so angle C so angle C is 28.9 degrees. And then so for angle A, angle A, 180 minus 28.9 minus 17.6 should give you the other one. 180 minus 28.9 minus 17.6. Enter. 133.5. And I don't know if I made an error there. I'm a 1/10 of a degree off from what they said. I'll backtrack right here just 1 second. 8 times sine of 17.6 close, divide by 5. Enter. All right. And then I did sine inverse. So second sine inverse, and I dumped all that in. And so I had 28.9. And so they were probably rounding earlier. Nothing wrong with my answer. Okay. All right. So that was using law of cosines. Again, you had to because you did not have a pair to start with. All right. Next, we're going to look at our last topic, which was finding the area of a triangle. And it would depend on what you're given, whether you are given side angle side or whether you're given 3 sides. If you're given 3 sides, you will use Heron's formula. You will find the semi-perimeter, and then you will use the square root of the S. You have to know these formulas, all right? And there's your formula. Or you will use the formula down here, 1/2 times, this is the angle between the sides that are given, BC times the sine of A, or whichever ones. All right, so let me get a new screen. And see if I can paste that triangle. Okay, and so here I have side angle side. And so it will be the not Heron's formula, but the other one. And I have, let me label, sorry, I am getting part of that other picture on my screen. Let's see if I can get it to move. Sorry, I have too many screens open. Okay, I have to go back up here, this one, to make it work. All right. So let me label these. This is going to be side A equals 3. This is side B equals 4. And this is angle C that I know. Okay. All right. So, from my formula, I have the two sides. I have sides B and sides A. So A and B, and I have the angle in between C. So I need this formula. A equals a half the sides that I know, A and B, times the sine of the angle in between. Right? And so then you're just going to plug in a half times side A, which is 3, times side B, which is 4, times the sine of angle C, which is 85 degrees. So it's just a matter of plugging in to your calculator. So half, you can put a half or you can put 0.5. It doesn't really matter. We'll just put 0.5. Whoops, 0.5 times 3 times 4 times the sine of 85, close, enter. And this says to do 2 decimal places, and so it is 5.98. And they tell you it is square units. Area is always square units. So it's not going to get any easier than this, but you have to remember the formula. So these are the sides that you're given, the angle that's in between, and you were given A and B. So sides that you're given, the angle that's in between, and it's all multiplied. So this is 5.98. Right? And let's see if I have one of the other kind, which uses Heron's formula. I don't know what problem we're on now. I think that was 9. So we'll do one more page and see if I have one for Heron's formula. And I'm just going to look for a second and not pause it, okay? So a side, side, side. So give me 1 second to get a triangle over here. So 4, 5, and 8. And the question is find the area. Okay, so they are giving you side, side, side. 3 sides, so you will need Heron's formula. The directions are going to say find the area. All right. So you have to find the semi-perimeter. Which is 1/2 times the sum of the sides, a plus b plus c. This is a. This one is b. This one is c. So half a is 5, b is 4, c is 8. 9 and 8 is 17. So you're getting 17 over 2. Not very pleasant there, but that's okay. Let's see. We're going to do, now our area formula is the square root, the semi-perimeter, and then the s minus each side. So 17 over 2 and 17 over 2 minus a, which is 5. 17 over 2 minus 4, and 17 over 2 minus 8. We might change that to a decimal. Let's see what we can do here. Alright, so let's switch 17 divided by 2. 8.5. So let's switch all this to 8.5 times. Alright, so 8.5 minus 5. So this is 3.5. And 8.5 minus 4. 4.5. 8.5 minus 8. 0.5. And now we have to multiply all of these. So let's go ahead and do our square root. So second square root, and we'll do the multiplication underneath there. So 8.5 times 3.5 times 4.5 times 0.5, close, enter. And so I am getting 8.18. And let me just check if that is the right answer. Yes. So see how I switched? I mean, because that's kind of a pain that you got this fraction. It was easier to work with decimals, so I switched it over. I wrote it down, plugged it in, but switched it over. Okay? Make sure you know your formula, but you can switch the form of the numbers. Okay?